Hello guys, I am Ali Jawad and welcome to my YouTube channel. This is our lesson number 3 on chapter 7 pressure of syllabus physics 5054 for Cambridge and O-level students. So those viewers who are new to the lesson, they are requested to go for lesson number 1 and lesson number 2 so they may have a better understanding of today's discussion. For their assistance, I am providing the link over here in the video. So in our lesson number 2, we have discussed and introduced the concept of atmospheric pressure, that the pressure which is exerted by the gases surrounding the earth is known as atmospheric pressure. These gases include nitrogen, oxygen and carbon dioxide respectively, while the other gases have very small percentage of it, including water vapors in the environment. So they surround the earth like an envelope and exert a pressure on its surface, which is known as atmospheric pressure. The atmospheric pressure varies with height. So as you go near the sea level, the atmospheric pressure increases because all the gas molecules are being pulled towards the sea because of gravity. And as you may move towards the higher altitude, such as mountainous areas, the atmospheric pressure will be low. And the reason is that all the molecules are being pulled towards the surface because of gravity. So there will be very less number of molecules at a higher altitude. So that is why atmospheric pressure decreases as you go higher and higher. We have also introduced the concept of barometer, an instrument which is used to measure the atmospheric pressure. Here it is. In a barometer, there is a small tube which contains mercury and is inverted on a trough filled with mercury. So let us see how this works. When the barometer is inverted, and so there are two types of pressure. One is the pressure of liquid and what is the atmospheric pressure. So atmospheric pressure pushes the liquid in the trough downward, which causes the liquid in the tube to fall or rise. And this happens until unless the atmospheric pressure, which is outside the tube, becomes equal, which is inside the tube. So this is how barometer works. The liquid can be mercury or can be any other liquid, but there are some restrictions that what kind of liquid can be used. It should not evaporate easily and it should not have very high viscosity, because otherwise it will get hindered while measuring the atmospheric pressure. So now let us see with the help of an example that why it is not feasible to make a barometer of water, or replacing mercury with water is not beneficial in barometer, and why it is so. Let us see with the help of this example. This is compare the barometer containing mercury with the barometer containing water. So it means there are two barometers. One barometer contains mercury in it, and another barometer contains water. If both of the barometers are placed in an environment where atmospheric pressure is equal to this, then calculate the height. So density of the mercury and density of the water is given to us respectively. Now we are going to use the same equation for hydrostatic pressure, which we have developed in lesson number 2. So pressure is equal to rho, which is representing density, times gravity times height. So when we are solving it from mercury, the pressure in which the barometer is placed is 103,360 Pascal, while the density of mercury is being substituted. The gravity is 10 for the surface of Earth. For those students who are following the syllabus of 2023 and onwards, they need to use 9.8 instead of 10, while height is unknown. So when we have determined the height, it is giving us 0.76 meters. It means that the mercury in the barometer or in the tube will rise up to 0.76 meters. Now let us see what will the height of water be in the barometer if instead of mercury we may use water. So We are using the same formula which is developed for hydrostatic pressure or the pressure of liquid in lesson number 2. The pressure is same, 103360 Pascal. The density of water is being used this time. So rho has been replaced with 1000. The gravity is going to be same because we are calculating on the surface of Earth, and height is h. So by this we are getting 10.36 meters. So now imagine replacing the water with mercury has a drastic effect on height. It has increased more than 10 times because if you multiply height with 10, it will be 7.6. So the water is not actually giving 7.6, it is giving even beyond that. It means that when you are using water in a barometer, you need a very large tube to contain the amount of water for the same pressure. And constructing the large tube and handling it during the experiment is a tedious task. That is why it is not recommended to go for selecting water as a barometric liquid. So this is how we can compare different liquids, that what will the effect of the different liquids be when they are used in barometer, and what height of the tube of the barometer will be required. I hope you have liked the lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you for watching.